special right triangle we looked at was called a 45-45-90, and we went into detail on how to break out the picture and always know that it was an isosceles right triangle. To learn how to deal with the side lengths, we worked with this chart. And we said that after we got the numbers, we also could plug it back in to Pythagorean theorem to check our answers. If we'd used a triple or it had not had any kind of irrational number involved in the answer, everything would end up perfect and equal. If there had been an irrational number involved, your c squared value compared to this side of the equation might be very slightly different. But here's what we did if you recall. Instead of calling the sides x and giving the proportion, we called each of the two sides the legs of the right triangle. And since the hypotenuse is the longest side of the right triangle, and it's across from the right angle, and it's proportional to the lengths of the legs, we called it L square root 2. The square root of 2 is 1.41, goes on a little bit further, but it means the length of this is 41% bigger than the legs. So if this leg equals 5, we said this leg has to also be 5, L equals L, and this was 5 square root 2. And in class, people began to raise their hand and go, I get it. So if this one's 8, then this one's 8, so that's 8 square root 2. And we're talking about any isosceles right triangle, so I'll kind of jot one in here. This side's 5, that side's 5, then the length would have to be 5 square roots of 2. If this side were 8, then that side would have to be 8, but the hypotenuse would have to be 8 times the square root of 2, which if we put on the calculator, I'm just going to do 8 times control square root 2. Calculator's going to give me a decimal answer, and it came up to be 11.3137. That's a very good answer, but it's very awkward to write all those decimal points. I'll put it in as reference, but we're lazy and don't want to write that. It's so much easier to write 8 times the square root of 2. Well, here, if L times the square root of 2 represents the length of the hypotenuse, and this hypotenuse is 3 times the square root of 2, that means our legs are each 3. And again in class, people said, well, if this leg is 4, this leg's 4, this is 4 square root of 2. If this hypotenuse situation that comes next is 10 square roots of 2, and you can always represent the ratio between the legs as this, that made 10 equal to the legs. And everyone did fine to that point. So I just highlighted this line here to show the math's going to be a little bit more challenging as we move down, but still very doable. I'll move our sheet up some. Certainly the pattern's the same. If one leg equals 13 times the square root of 2 over 2, then the other leg is also 13 times the square root of 2 over 2. Then to get the hypotenuse, we have to take whatever the leg is, so I'm rewriting 13 times the square root of 2 over 2, and we have to multiply it times the square root of 2, because that's what we always do to get the length of the hypotenuse. We take the leg and multiply it times that 1.41 number I told you about. So if I do this times square root of 2 over 2, this square root of 2 would be in the numerator. It's like it's over 1. This is down the denominator. Excuse me, this is also in the numerator. And so the square root symbols cancel each other, and just the 2 is left. So we have 13 times 2, but the 2 that was in the denominator here comes there. Now is when I should have crossed out the canceling. This 2 in the numerator cancels this 2 in the denominator, and my answer is 2. So I just went back and tried to clean this up a bit where I accidentally drew through that, because square root of 2 times square root of 2 will give us this 2. I'm going to show you on the calculator. Square root of 2 times square root of 2. Oh, just a minute. It didn't work. Times See if that's going to work. Okay, I did too much. Just a minute. Let's go doc the control square root 2, arrow out of the radical, times control square root 2. There. There you go. Square root of 2 times square root of 2 will always equal 2. So let's try another problem. Let's look down here. What happens where instead of having the square root of 2 as part of the hypotenuse, you have a whole number? Problems are super simple when the legs are the whole number and we slapped on the square root of 2 to make it 41% bigger. And maybe I should write this here too. We'll go control square root 2 and hit enter. So you see it's 1.41421. Just going to make a note up here at the top. Square root of 2 equals 1.41421. So when I say it means that hypotenuse is 41% bigger, you see where I'm getting that value. So now I'm going to give you the short answer on how to work this right here. If 22 is hypotenuse, in order to get the legs, all you have to do is multiply it times square root of 2 over 2. It's because we're raising the denominator and it will work every time. So I'm going to go 22 times square root of 2 over 2. And of course I remember to look at the 22 in the numerator and the 2 in the denominator and reduce, and I get 11 square roots of 2. If this is 11 square roots of 2, then this is also. You say, Mrs. Morris, how did you know to do this? So I'm going to walk you through the steps on how to rationalize the denominator. But in the end, I think you'll want. I know that 22 is my hypotenuse, and it equals L, whatever the legs are, times the square root of 2. So just like in algebra class last year, I divide both sides by square root of 2, and I end up with 22 over square root of 2 is what equals my leg. Great answer, but the problem is you're never allowed a radical in the denominator. So the only way to get rid of it is to multiply it by something that equals 1, but would make that go to a whole number. So that's square root of 2 over square root of 2. Because it looks so ugly, I call it ugly 1. I kind of do a big, fat, bold 1 around it. You can picture that being like a big, fat 1. It won't change the size. It just allows us to go 22 times the square root of 2 equals 22, just beside square root of 2. Square root of 2 times square root of 2 we did in the calculator, and we got 2. We're going to reduce that fraction, and we'll end up with 11 times the square root of 2. The exact same answer we already put in right there. Okay, so let's do these last two that just deal with and the rules I published for you early in the unit. If one leg is 7 square roots of 2, we're on a 45, 45, 90 still, so these have to match. And to get the hypotenuse, I take the leg, which is 7 square roots of 2, I multiply it times the square root of 2, and I end up with 14, based on what we've been discussing of square root of 2 times square root of 2 equals the square root of 2 squared. And the square root and the square cancel out, and you end up with 2. So you just get 7 times 2. For this one, if one leg, I'm coming to the last problem, is 6 times the square root of 5, the other leg has to be the exact same. And the hypotenuse, you would take that leg, multiply it times the square root of 2, and for the radical rules I published for you, the two numbers under the radical get multiplied together. The one outside stays the same. If the number underneath the radical gets big, you have to be sure and reduce it, how we've learned to simplify radicals.